I'm Dr. Rosemary Francis, Chief Scientist for HPC, and together with my colleague Ian Littlewood, the Product Manager for Cloud, we're going to demonstrate cloud bursting with Altair Control. Altair Control lets you burst from on-premises HPC compute into the public cloud. It sits alongside Altair PBS Professional in order to deliver hybrid cloud supporting a number of public cloud vendors. This diagram shows a typical architecture where you have PBS Professional running on your compute resources and you burst over a VPN to public cloud. So now let's look at the demo configuration. We're going to burst to two different clouds. We have an MPI workload that's going to run on Oracle Cloud and an SMP workload that will run on Google Cloud. Now our customer uses two different clouds for capability and capacity. Oracle Cloud delivers the GPU nodes and InfiniBand on bare metal that is needed by the MPI workloads, whereas Google Cloud provides the business model that suits the high capacity needed by their SMP workloads. First of all, I'm going to show you how to get started in Control by registering your cloud accounts, and then we're going to look at how to set up scenarios. If you take a look at the user interface, you'll see that we have options to register your cloud account for each of the major cloud providers that we support. It's just a question of clicking on each of those buttons and filling in your credentials. Next, we're going to look at how to configure the bursting scenarios. Scenarios are how you control your cloud environment. They allow you to lock applications to specific instances to make sure that they're only using compute resources that have been benchmarked and you know to be suitable. You can have multiple scenarios for each cloud supporting different applications, matching different application profiles. In this example, we're going to have two scenarios, one for our MPI workload on Oracle and another for our SMP workload on Google Cloud. These instances have been selected for our SMP workload, and you can see that we've enabled spot pricing. The idle time before unbursting configures how long a node will wait around before being taken offline. And then we have the SSH keys that let us connect to the instance. Finally, we can define quotas in the cloud orchestration platform. This lets us set things such as how many instances of the node can be spun up at any one time. We can also set up alerts when the number of instances hit a certain limit, and this is just another way in which you can control costs when using Control in the cloud. So we're going to show how Control can be used to automatically burst to the cloud based on demand. We're going to submit one MPI job onto Oracle Cloud, which needs two nodes, and we're going to submit 4 SMP jobs on Google Cloud. Those will be sharing 2 nodes. Control uses workload simulation to correctly provision the right number of instances for the workload. So Control will correctly identify that our 4 SMP jobs can share 2 nodes. And we're also going to use budget management for users and projects to ensure that we don't overspend. So I'm now going to hand over to Ian to submit those jobs.
So submitted those jobs and we can now see those queued. So the next stage will be that the Cloud Toolkit will see that workload, work out the resources needed for it, and request 2 nodes in GCP and 2 nodes in Oracle simultaneously. So now we have our workload queued, but there's no resource to run it on. So if we look in the user interface here, what we can see is that we've got 2 nodes currently being provisioned in the Oracle Cloud Platform, and we have 2 additional nodes in the Google Cloud Platform. So those instances will be brought up, they'll be configured, connected back to the workload manager, and once they're connected back, then workload will be dispatched to run on those. So around a minute later, what we can see, we'll recheck the queue. Currently, we can see the VMs have finished provisioning. They've been attached back to the workload manager and they're ready to run job. And if we look a little deeper in the PBS configuration, we can see that we've got cloud nodes added to the system. We can see one here added by IP address, and we can see that there are jobs running on those VMs now. So that whole process takes somewhere around a minute to orchestrate. In the meantime, if we go back to our Altair Control Cloud interface, we can see that the Oracle bare metal instances have now completed provisioning. We see that because we've now got IP addresses associated with them. If we go over to the Oracle Cloud interface, we can see those resources stood up in that platform. And then if we jump over to the command shell we're using and recheck the queue status, we can now see that that resource is recognized by PBS, and the MPI workload is running on those bare metal instances. So as soon as all the workloads completed, our platform will take down the resources to stop incurring costs for hardware that's not performing any useful workload. So we can see here that the notification count changes in the control interface, and if we look, an undeployment workflow has started. If we jump over into the Oracle interface here, what we can see is that the hardware is being deprovisioned and terminated, and that once that is complete, if we return to our user interface, we can see that our workflow for terminating that hardware has completed. And there's a lot of management involved with those things because, for example, when you're using InfiniBand, there's layers of entities that need to be created in the cloud platform, and we automatically manage all those layers on your behalf.
Thank you for listening. Please stay on this channel to see how you can configure budget to control and manage costs in the cloud.